If anyone would like to talk to me and is afraid of mispronouncing my name, Zeljko translates as Bill. So it's Bill and Bob for this morning. Good morning, everyone. It's great to see you, many colleagues and friends. Finally, we can meet in person again. This meeting series is very important to Rubin and LSST science. And it's great to see that there are about 200 people on Slack. And I don't know how many exactly people are here in person and on Zoom. But it's great to see that we are all trying to prepare together for LSST science. And Rubin team knows and believes that Europe will provide some of the best science results in LSST. And that's why we are present here with a very strong team. If you look around, some of our key leadership is here, which testifies that we think of this meeting series very highly. So for this morning, we'll have 90 minutes and I'll go through a few slides in 30 minutes, then Bob will replace me, and then we leave 30 minutes for questions for both of us as well as discussion. If there is a question of clarification, then please do interrupt me or Bob, but otherwise, let's leave serious questions for these last 30 minutes of discussion. That's Bill and Bob on the picture at the summit. So my talk will be pretty much a slide safari. I want to show you that there is a lot of hardware at the summit. There is a lot of software being tested. We are approaching the end of construction. And then Bob will show you slides that will probably contain more useful information to you because they will be more useful, more focused on when exactly you will get data products, what kind of data products, and what you will be able to do with them. So let's continue. So there are two things I want to discuss, 5 points of construction progress, basically to convince you that we moved from design pictures to photographs of real hardware. And indeed, I went through Sandrine's talk, our telescope and site project scientist and deputy director. She produced a beautiful slide where she compares computer design pictures and the way the stuff looks today. And then I'll talk a little bit about schedule at the end. We are slowly recovering from the major impact that COVID had on the project. We lost more than 2 years of time. We finally reassembled in person. That's from this August. That's our 300 plus people in Tucson. And there were almost as many on Zoom. So things are getting back to normal, but we are not there yet. You can look around and see masks on your face. We are still losing time to effects that are related to COVID impact. Meanwhile, there was also some major leadership changes. Steve Kahn, who was director since the beginning of construction, accepted the position of Dean of Arts and Sciences at Berkeley, UC Berkeley. So we had to backfill some positions. I stepped in as director, and then we appointed new deputy directors, Sandrine Thomas, who is here. She's telescope and site project scientist, and Aaron Rudman, who is the lead for the camera work. And the camera project scientist, Steve Reitz, was also appointed as the project scientist for the whole project. Another important change in organization of the project was to respond to the fact that system integration, testing, and commissioning is becoming more and more complex as the subsystems, as the telescope, camera, and data management are completing their deliverables. Now we have to put them together, integrate, test, commission, and deliver to Bob Blum and his operations team. So that's becoming now much more complex undertaking. So we split the original unit we called Sitcom to 3 individual teams that are still closely cooperating, but each one has these 2 in a box leadership. We have 6 new people in this purple box. So we have system verification validation, we have system integration, and we have system commissioning, and the commissioning scientist, Robert Lupton, is also present here. Who? Oh, Austin is present too. Cool, I haven't seen him around. Excellent. So let me now show you a few pretty photographs from the summit. That's a few months old. It looks kind of distorted. Sandrine, tell me, is that distorted a little bit? It's not that long compared to the height. So that was the moment when we put the top ring on the telescope mount assembly. As you know, the dome is being completed by an Italian company, and the telescope mount assembly was produced, constructed, and delivered by a Spanish company. So there is very strong European participation in Rubin Observatory construction, and there will be in operations. For example, France and UK will participate in data processing in a very significant way. And I think Bob may tell you more about it. Here is another shot of this telescope mount assembly. So it was disassembled in Spain, delivered to the summit and reassembled. It now moves under its own power and software control. There is very nice little YouTube video that you can access, watch later. The thing really moves. Here is a quick shot from the 3rd floor at the summit building. In the top left, you can see our commissioning camera, which from the outside looks pretty much like the main camera, but it only has 9 CCDs. And the motivation for producing that instrument was that we can shorten integration and commissioning time while the camera, big camera, main camera is still at SLAC in California. We are already now performing integration and commissioning steps with this camera. In particular, it will be useful to complete the telescope as well as to test software end-to-end. Top right shows mirror washing station. So every few years we will be re-aluminizing or probably re-silverizing mirrors. And so that we are not going to take mirrors off the summit. Everything will be done in that big building. You can see secondary mirror, bottom left. And bottom right is another example of European participation. That's a coating chamber where we will be coating both mirrors, or all 3 of them indeed. And that was produced in Germany. A German company delivered coating chamber. And ComCam, as I said, is already in the commissioning mode. It's taking data, not on sky data. It's taking essentially laboratory data. But you can see that these 9 CCDs, they do work. You can see one of the first light images with ComCam. Much more detail about ComCam you can learn here from both Steve Ritz is here, who is camera project scientist, as well as Robert Lupton, who is leading commissioning. So if you're interested in those aspects, please do talk to them. Here is another integration example where we used ComCam to insert it into telescope mount assembly, essentially practicing for the moment when next year the main camera will arrive. And then we'll have to lift with that yellow hand, that yellow arm, we have to lift an instrument that is more than $100 million worth. So you don't do it without much careful practicing before. And this is one step in that elaborate procedure to get us ready to be brave enough to lift the main camera next year. Here is a photograph of our summit control room. So essentially that control room is operational. We are using it for so-called auxiliary telescope observations. Auxiliary telescope will be used for calibration. In operations, it will take spectra of bright stars, and spectra of stars that intrinsic spectra will be known for those stars. So from observed spectra, we will deduce what is the atmospheric transmissivity on that particular night. And then we will fit models to increase wavelength resolution. And so we will be able to correct our photometric observations for color terms, not in a traditional astronomical way by assuming some fitting functions, but actually to solve it from first principles by evaluating integrals that give you these corrections. So it's operational, and data are being flown from Chile to US data facility in an automated fashion. Software frameworks are being tested. So far, so good. Again, Robert can tell you 1,000 times more than me about details if you are interested in that particular aspect. On the right, you can see M2 surrogate installation. So we are now practicing with surrogate mirrors, and early next year, we will start integrating the optical elements. And here, if you want to learn gory details, please do talk to Sandrine and other members of the team from Telescope and Site. She's the one who knows most about it here. This is a slide I stole from Robert. I don't know if he will repeat it eventually, but it basically summarizes that we are using auxiliary telescopes for real on-sky observations. Auxiliary telescope has real Rubin CCD. It's engineering grade, but otherwise it's not real CCD. Oh, it's not engineering, even better. So it is a real CCD that we are now exercising in our software framework. Now moving to California to SLAC, here are some of the older images of the camera. So on the left, it's not fully assembled. You can see trunk with electronics. You can see cryostat, but it's not completely assembled. On the right, you can see our largest lens, L1. Maybe you remember from kindergarten that the largest astronomical lens was Zeljko's Observatory telescope refractor. This one is larger. It's already in the Guinness Book of Records, the largest astronomical lens ever produced, 1.57 meters. On the right, you can see our filters. All 6 have been delivered. They're also quite large. And you can see shutter in the middle bottom. So these were the pieces. And just recently, the camera was fully assembled. That was the first time that camera subsystems were all together. I actually don't know if that no tweet policy is still in effect. Did we have press release still? We did. So you are free to make pictures and redistribute this. Here is the picture of the focal plane. So there are 189 CCDs for science plus 12 more. And together they're about 3,000 megapixels, 3 gigapixels. And it's operational. We are doing a lot of electro-optical testing. I believe that all the data that our team took in California for testing of this camera is more than the entire SDSS imaging survey. And on the left, our subsystem scientist for data management, Lian Guy, who is also here, noticed that we are using imperial units instead of SI units. So I was corrected. I added centimeters for feet. So the camera works. This is a picture of Vera Rubin, who the observatory is named after. She was a pioneering astronomer studying dark matter. You can see in this image that there are not many glitches visible to the eye. Each CCD has 16 amplifiers to enable very fast readout. Our readout time is 2 seconds only. And so there are 3,024 amplifiers, only 3 did not meet the specs. So it's, from that point of view, it was rather a great success. Right now, camera will be subjected to additional electro-optical testing. We want to fully understand quantitatively its behavior before we ship it to Chile. And here is collage of various tests that the team is doing. And if you want to learn more, please catch Steve Ritz and others from the camera team and talk to them. We do have 2 different types of CCDs from 2 different vendors, one American, one British. Sometimes people worry that this could cause problems for scientific work, but as you can see on the right, the differences in QE curves between those 2 CCDs is comparable to what you get from just looking at different air mass in the atmosphere. So we have to calibrate these effects anyway. So even though we'd prefer to have single type, this is not major obstacle for eventual science from LSST. Here you can see some quantitative measurements. In particular, in the middle image, you can see the read noise map. Our requirement was, I think, 9 electrons, median of 9 electrons, but you can see on the histogram on the right, I think about 90% of our sensors meet that spec. And again, the story is slightly more complicated. You can catch Steve Ritz and talk to him about it. Probably most of you heard about our challenges with the refrigeration system in the camera. There are 2 refrigeration systems. One that we thought originally would be harder to produce that cools CCDs to minus 130 centigrades. And the other one that cools electronics to minus 50 or so, that essentially should work like your home refrigerator. except it's much higher power than your home refrigerator, much more constrained volume, and much greater stability requirement. So to make the long story short, we realized that it wasn't stable enough. We're looking for mitigation effects and realized that instead of having refrigerator in the camera, we'll take it out. So now we have commercial refrigerator far away from the dome, and we'll ship -50 centigrade fluid from that chiller into the camera. So thermodynamically, it's much more robust system, and we passed final design review this August, and in few weeks, we will remove some pieces of hardware from the camera to account for the change, and we'll be good to go. So here, for example, you can see some new elements we produced for that, like cable wrap on the left. In the middle is that commercial refrigerator, which now has much more volume to work in. And on the right is a model that we are using in California to test our simulations of temperature distribution with this new system. Quickly going through data management. As you know, DPDD is our source document for data management and what we will be delivering to you to do science. All the data products are described there. And to some extent, hints are given about algorithms. And then there is another document that goes deeper into the algorithmic description. So I think you'll learn much more from Yusra in her talk, but this is the basic outline of our pipelines. It's conceptual. It's not exactly how it works in practice, but conceptually, there are these 8 major pieces. So on the left, those yearly processing is similar to what other big surveys did, like PaintStars or SDSS or Dark Energy Survey. And that on the right is more similar to what surveys like ZTF are doing, where they try to give you real-time information about what's changing on the sky. It's more involved than that, but conceptually, that's how you can think about it. Here are the 2 images that demonstrate progress in 2 different ways. All software experts know that the lines of code are not a good metric to measure productivity. But on the other hand, it's nice to see that lines of code are growing. And in particular, that straight line fit, this red dashed line, doesn't show any strong effects of COVID. So at least in that one metric, which of course is not perfect, things are looking good. Perhaps more accurate diagram is on the right, which project managers like more. Everything the data management team needs to produce was defined in about 250 milestones. And so there is a expected line, blue line, and the orange line on the right shows how the team is actually doing, and they're doing great. Here are too many words to read. I put this slide for completeness. I think I stole it from Willow Moulin, our project manager for data management. But a few things to highlight or to emphasize are that our software has been used in production for many years because both Subaru HSC surveys are using it for their data processing, and ZTF is using some parts of our code for their alert distribution. And again, in commissioning, we are using pieces of code. So it is unlike some other cases in astronomical survey history where you come to first light, and that's the first time you actually start testing your software. In this case, it's somewhat different. Also, you may have heard, especially if you're an international collaborator, that we went from NCSA being main processing center to Department of Energy Lab, SLAC, hosting US data facility that will be processing Rubin data. That's ramping up rapidly, and we switched off NCSA support in August. Here is a quick picture from Will about data facility at SLAC. And coming to the 4th subsystem, education public outreach, they are actually coming close to the end. In few weeks, they will have the final review, and officially they will be done with all the products that they produced, and they're formally then becoming part of operations team. So these people will remain with us, but formally they are switching from construction to operations mode, funded from a different pot of money. I added this slide because all these bullets on the left are live links. If you download the talk from the conference website, you can follow these links and see what they produced. In particular, there's a nice little game that simulates our scheduler. You can try to think as our scheduler and try to catch supernovae, asteroids, and everything else in the sky. Yeah, I did too. I boosted my score from 12 to 25. So let me come to the end of my part. So here is the list, short bullet list of the things that worry the most our project leadership. That's where we spend our time discussing how we can improve this, how worried we should be about it, can things be done better? So I think the top two are still camera refrigeration system. Until we see camera working again and doing electro-optical testing, the first bullet will remain on the list. Hopefully COVID will be gone soon. Hopefully our Spanish and Italian subcontractors will be done soon. And then one worry is how things are done in the end game phase when things become more complex. You are limited by time, you're limited by funds too. There is limit on both of these and we have to fit everything in that period. So that's what worries us. Fortunately, we are not classic case of construction where one team constructs the thing like say nuclear power plant and delivers to a completely different team that will run that entity. In our case, about 80% of our people from construction will continue into operations. And that's an important point when you think about how often close to the end of construction, people look for new projects. They go to new exciting projects, and then you are left with half a year at the end, half a year worth of work with half the crew. So hopefully that will not happen to us. And then dates. As you know, we've been slipping and slipping and slipping, mostly due to COVID, although not exclusively due to COVID. And so people have to prepare for science. You have to write grants. You have to plan, say, PhD projects for your students. So it is very challenging to have project tell you every 6 months we slipped by another 3 months. And that's what was happening during COVID. And after a while, it is very hard to follow what exactly is the official schedule. Which slides do I look at? You can Google and you get slides that are 6 months old that don't even have dates when they were produced, and you look at some schedule and it was difficult to follow that. So we decided in the project that we will just publish our monthly updates to National Science Foundation. We report on monthly schedule to our agency. Actually, our program officer, Ed Ajar, is here. Say hello when you see him. He receives these updates. So this is public website, ls.st dates. Whenever you want to check what is the latest schedule for Rubin, you can go there. We selected for you 10 top milestones that are easy to understand. And here are 3 of those 10. So these dates are still valid. We really hope that we'll get engineering first light with the LSST CAM around summer next year. And then the first images with the big camera will be available in March of 24. And Bob will tell you more detail about start of operations, start of LSST, as well as the uncertainty ranges that we still have in his talk. So I'll not go there. I'll just show you a couple of more photographs that it's not just COVID. There are other non-Gaussian things. This was snow. One of the worst snowstorms at this time. It's so bad that some astronomers had to be evacuated by helicopters from the summit. We couldn't open, for example, doors to get into our observatory. Some hardware was broken, etc. So things happen. That's why we need to adjust schedule. That's why we need to carry schedule and budget reserves. But I am convinced that we will get there. Our team is very strong. Over so long time, over a decade, we became almost like a family. I don't anticipate any major problems, but I cannot promise schedule to you that is more accurate than a few months because there are still too many uncertainties. So I will stop here and invite my dear colleague Bob to take over. And then we'll have discussion after Bob is done.
Ciao, buongiorno. It is wonderful to be here with you. Thank you, Dragana, for the wonderful introduction. I agree with Zeljko, it's too kind. But it is a great pleasure to be here with you all. As Zeljko said, really important part of our community, and we're happy to continue to work and build our collaboration together to succeed in this fantastic project as we go forward. Okay. Oh, Zeljko, you had one more slide up there, which I think everyone, oh, I went backwards. That was my, okay. I'm going to go through a few slides, and then as Zeljko said, we hopefully will have an interesting discussion with you and answer your questions and continue to talk about where we're at with the project. I'm going to go over some status of the operations, some things that we've been doing this last fiscal year. Talk about our data preview, which I think many of you know about, our in-kind program, which certainly many of you are interested in, some sustainability initiatives that we're excited about at Rubin Observatory and Noir Lab, and hopefully that's something that you all will join in on as we go forward. The scheduling, the survey cadence optimization committee, progress there, our users committee, some thoughts about research inclusion, which I think are appropriate to all of us, and just introduce some new staff members that are coming on board as we go forward. So this has actually been a really good year for us in the operations side. As Zeljko said, we continue to have challenges with COVID and getting the project going again, but it's making progress on all fronts. On the operations side, we had at least 3 big accomplishments this year. Earlier in the year, we republished the initial survey cadence, updated to version 2, and we're looking forward in another few months to having basically the final cadence ready for the survey that we will continue to optimize and tweak, but this will be the last big change, we hope, as we approach the beginning of operations. And then in February, we actually had a joint agency review for NSF and the Department of Energy, and I'm happy to say that it went very well. The operations team presented our operations plan, our staffing plan, and our budget for the next 5 years, which takes us into the first 3 full years of operations. And that plan was basically approved by the agencies. And so now we look like we're in good shape to start the survey with full funding as we go forward. So that was really good news. And then we continued with our successful data preview program, which I'll say more about in a few minutes, but we launched again with reprocessed data products from our simulated data set in June. And many of you, I think, are involved in that as delegates to that program. One of the biggest things that we're interested in doing as we approach operations and we transition from construction is really building the user experience. After all, what we're all about is providing data products so people can do science with them. So on the left here, you see an image from Hypersa PrimeCam actually on Subaru, which is very similar to what we expect the result from the LSST survey to be, only multiplied by about 3 million times on the sky. So you can see it's a tremendous challenge for anyone, whether a beginner or an expert in astronomy, to be able to handle that amount of data and make sense of it and productively do science with it. So that's really our challenge, is to make sure the users can productively use this incredible data set. On the right, you see a plot of how that data will grow over time from year 1 through year 10. So as soon as we turn on, we're going to have more data than most other surveys have produced over their entire survey period. Certainly by 10 years, we'll have hundreds of petabytes of data products that will be available to the community, an enormous challenge for us and for our users. So our goal then is to democratize science and make this data set available and easily used by anyone, whether they're an expert or a beginner. We want to have abundant and discoverable documentation so that people can understand the data products and how to use them and the tools. There has to be clear entry points, no matter where you are on the scale of expertise, so you can get into the right place and get the right tutorials and information. Our support model has to be such that we can't handle it individually by having a scientist talk to every user that has an issue. So we have to have an asynchronous support model that is online that people can connect to, and that is actually supported by other users. So kind of a crowdsourced support model, and that's what we're building with our community engagement team right now. We want to have a stable software and compute resource model for you all to use so that you have reliable resources to do the analysis of the data as you go forward. We're trying to prioritize research inclusion and have that expertise throughout the community, including in places where it hasn't traditionally been in astronomy, because there's lots of folks, especially in the US, who haven't been able to connect directly to frontline science because they haven't had the resources. Rubin and the LSST provide those resources without having to have access to your own telescope. What we have to do is be able to just provide that data so people can get to it and understand how to use it. And we want to make sure that anyone can become a power user and push to their level of what they want to accomplish with Rubin as we go forward. One of the key things that we're doing between now and the start of operations is a so-called set of data previews. You can think of these as shared risk data releases. So they're a key operations readiness activity, both for our team to understand how we process, do a campaign of processing, put that data out and make it available to the community, connect with the community, make sure they know how to use it, train the community on how to use the tools, and then get the science done, and then feed their experience back into what we're doing. So it's really a complete cycle that's helping us get ready for operations. Currently, we have 3 data previews planned. The first one is DP0, and that we split up into 2 pieces. It's based on the Dark Energy Science Collaboration Simulated Data Set for Rubin, or LSST. I'll talk about some details of that in a minute. DP1 will then be the science valid data sets coming out of the commissioning camera that Zeljko just described. And DP2 will be the science validation surveys right at the end of commissioning with the main camera and facility. And we'll package those up and process them. And then some point after those commissioning phases are done, we'll provide those to all the data rights holders through the Rubin Science platform. This image on the right is just a screenshot of what you would see in the landing page for the science platform currently. A few words about our current schedule. This is consistent with what Zeljko was just telling you. In February, at our proposal review, we actually had the start of operations in April of 2024. We're now looking at a date that's somewhat later than that. The project talks about a so-called forecast date. So that's the best estimate of when they will finish the construction project, but it has no uncertainty or schedule contingency added to it. So you can think of that as the earliest finish date, which currently, if you go to that website that Zeljko was talking about, would be July of 2024. We all expect that will go out a little bit as we go forward. We're currently looking at, for planning purposes, a late finish date. So with the schedule contingency and uncertainties factored in, something like late 2024. So you can think of that about a 6 or 7 month uncertainty in the finish of the project at this point. We will recover some more contingency, as Zeljko said, with the effects of COVID. So we'll build that back into the budget and schedule contingency as we go forward. We have now put in our field work proposal with the Department of Energy and our program operations plan with the National Science Foundation. So we're all set in the operations team to get going on the fiscal year 23, this next year of activities. Because of this shifting in the schedule, we have slightly reduced our actual ask for resources going forward in the next year because our schedule then for operations and pre-operations will spread out a little bit. As Zeljko mentioned, the EPO team has now started into operations. They were the first subsystem to finish their construction deliverables, and now they're going to go into operations. Of course, we'll be working with them with precursor data sets before the full survey starts. Their formal handover and closeout of their project will happen in about a month at the end of November. So we're looking forward to that. This schedule diagram shows that gap, which is most of the impact of COVID, and then it shows smaller bars of activity as we went through the end phases of COVID and then picked up again late in 2021. You see the red line there is the critical path, and currently going down to the bottom there at an operation start planned in about October of 2024. That's the date the operations team chooses for planning. Again, the forecast date was July of 2024 right now, and a late date of December of 2024. If we look at our current operations milestones, these are consistent with what Zeljko told you, but now we have some uncertainty applied to these. These are going to show you where we hope to hand data over to the community. So DP0, DP1, DP2, and the first data release. You'll notice that I have crossed out some dates and put in some new dates that happened over the last few weeks as we continue to evolve our schedule. You have to think of the schedule and what's happening right now, at least on the operations side, as a dynamic process from here to the end. It's never going to be exact until we actually turn over into operations. So we're going to continue to evolve our plan as we go forward. So what those dates show is that there's an uncertainty from, if we look at a data preview or a data release, from if we attach it to the early finish date that I was just talking about, or we attach it to the late finish date. There's also some uncertainty in the ability to process the data and then the time it takes to process the data. So it's not as simple as just saying when the project is done with commissioning and the science validation surveys, then we have the data. We obviously have to process them, validate them, and then make them ready for the community. So there is some time there. Actually, Leanne Guy is going to talk about the early science availability of these data in a dedicated session on early science, I think on Thursday. So we'll go a lot more into detail on some of these dates and the data products that we're making available. Here it is. So that's Thursday at 9 a.m. So hopefully we'll continue this discussion and answer your questions there. The schedule and the content of the data previews and the data release 1, which would be the first full data release within operations, follow from the best case of commissioning, so that hopefully that things go well in commissioning, and then we're set up to do the data release as we go forward. So let me say a few more words about data preview 0. This is to enable, again, our preparation of ourselves as an operations team and the community to use the data and the Rubin Science platform. We're showing end-to-end processing of what this will look like. We're taking the current as-built data management system and running it as an operations team through a campaign to produce, assuming we took the data on Sky, to produce a data release. We've integrated the science pipelines and the Rubin Science platform, and then we use feedback on these data products to help the next data release. The data set are LSST-like images that were produced by the Dark Energy Science Collaboration. We thank them very much for making those available to us and to the community. That was their data challenge 2. Future data previews will be based on the commissioning data sets, as I said. And the timeline is that in last June in 2021 and this June, we took that data set and made it available to the community. The difference here is that in the current version, we took the raw images that the desk had produced and we ran them through our own system of pipelines and as an operations team and produced the analogous LSST data products. Again, so the second preview was of the simulated images for DP 0.2. We reprocessed them. We expanded the cohort of delegates that are available that could access these to about 600. So we actually have quite a few people using DP0 right now. There are weekly, not weekly, there are bi-weekly or monthly so-called assemblies where they get together and work in real time online together to solve problems. And then we have our community engagement team that connects with these folks and solves issues that they have as we go forward. The DP0 data set itself was 300 square degrees based on a wide, fast, deep type of cadence. We simulated galaxies, supernovae, and stars, as well as some variable stars. There are imaging data products that include our process visit images. So basically what you would get after pointing at each region in the sky. There are deep coads and different images, difference images. The key is that in DP 0.2, we then added the ability to look at a time series or the source over time. So you could do that type of time series analysis. And they included catalog data products that had signal to noise, 5 detections, and force photometry on all those different types of images. This just shows a brief processing flow and shows the points where the construction team and the operations team each contributed to this effort. Yusra talk later today will go into much more detail, so I won't go through this in detail. But the main point is that we use this opportunity to really run through the whole thing. So as Zeljko said, we won't be coming into operations cold. We won't be just trying to start to learn how to do the actual campaign processing. When we get to operations, we'll already have a leg up on doing it with these data previews. The science platform right now, this on the left shows you the landing page. And then if you actually have an account, you could get in there and you would see these different aspects. So our portal aspect where you can explore the sky and find different objects, our notebook aspect where of course you use a Jupyter hub to do all sorts of analysis and connect with the catalogs and images. And there's also an API aspect, which would allow you to automate a lot of this analysis. So those are all the kind of things you can learn how to do right now if you connect with the data previews through that program. All right, let me shift now and talk a little bit about the in-kind program, which I think is of great interest to all of you. This map of the world shows where we have current active collaborations and in-kind contributions going on with our community. So we're clearly and really a global collaboration. There are 43 individual international teams comprising 30 countries and 150 or so individual contributions in this program. I think the total dollar value is something like $270 or $300 million overall. Two of the big contributions, as Zeljko mentioned, are that the UK and France will do processing, help us do processing of the annual data releases in operations. There's really a diverse set and scope of activities here. We have the offsets to operations, like I just mentioned. We have telescope time. We have independent data access centers and computing resources, independent data sets that can be combined with Rubin in interesting ways, and many directable and global independent software contributions. Aprajita Verma is here. She's leading our in-kind program coordination team, and she'll be leading a session on lots of details of the in-kind program Thursday. The motivation for this program was manifold. We obviously wanted to support operations and get as much support from around the world that we could, and we're doing that. We want to support US science, so we want to add value to what's available to scientists in the US through these contributions in exchange for the data rights. And we wanted to keep faith with an international community that we had a strong relationship with for many years before this change to the new model of in-kind contributions happened. And I think we're doing all of that. Of course, there are challenges. This is a big new management responsibility on the operations team to manage this whole program, as well on our science community, the so-called recipients, those groups that will have to take these contributions and make sense of them and use them to their advantage. You heard yesterday in the science collaboration talk by Will Clarkson that there's still a great need for resources in the science collaborations. They don't have as much funding as they would like. I would just like to make a pitch that this in-kind contribution, many of these contributions are things that can be used effectively by the science collaborations, by individuals in the science collaborations deciding to take a leadership role and connecting that individual in-kind contribution to some activity or program or project within their science collaboration to make it better or to do more science with it. And in particular, you could use that opportunity to leverage grant proposals. You could show that you're taking leadership to bring in extra resources to supplement a grant proposal, for example. So there's a lot of opportunity here I think that the science collaborations could take advantage of. It takes work, but there's a payoff and there's leverage and there's extra resources to be had. So if you have questions about that or you're interested in it, let us know and we'll be more than happy to explain what the opportunities really are. Let me say a few words about research inclusion. We feel at Rubin with this amazing data set will be a world best data set. If we're not able to connect with parts of our community that haven't been able to participate in frontline research up to now, then we're doing something wrong because we've removed many of the barriers to being able to participate. What it really takes is to be able to connect online, to be able to get access to education and documentation. And then you have available to you the science platform and the data set. So there's a great opportunity here to connect with parts of our community that haven't participated in research and top line education opportunities before. So we internally have established a research inclusion working group. We call it RIWG, and our goal is to make sure that we succeed in this. We want to build this inclusion in from the beginning. We don't want to do it as an afterthought. We don't want to get into operations and successfully start working and then say, oh, why don't we see if we can bring in parts of our community that haven't participated before. We want to do it at the beginning, build it in as we go forward. So it's part of what we do. Not an afterthought or an addition. So we have been engaging on an individual basis with what we call a cohort of underserved communities in the US. So we reach out to them directly, explain the opportunities that are available to them. And in particular, right now, we've been trying to draw them in and get them to participate at the level that they can and that they want to in our data preview program. We are coordinating with some true experts in this field. Darren Norman and Tim Sacco work at Noir Lab as well. Tim is a PhD sociologist and Darren Norman is a PhD astronomer working for Noir Lab. And as part of the US Extremely Large Telescope program, they have a grant to develop a toolbox of best practice for research inclusion. We've brought them in, lucky for us, to help guide us in best practice as we establish and go forward with this Rubin Research Inclusion Working Group. We've also hired a specific postdoc to take part in our community engagement team, just like any other community engagement scientist working with the community on the data releases and the data previews, but was the specific charge to connect directly to this underserved cohort. And that's been going quite well so far. That's Gloria Fonseca Alvarez, who's already started directly working with a number of folks in this cohort. And we're also coordinating with the corporation. You heard Beth mention yesterday the Catalyst program. So we're connecting directly with them, and Beth and Jenna Sokolowski both sit on our research inclusion working group. So we keep each other informed on what we're doing, and we try and leverage each other's activities to make progress in this area. Another big area that we are working actively with is between Rubin and Euclid. We have agreed with the Euclid consortium to observe the Euclid Deep Field South, and we're currently working on an MOU about how we would go about sharing basically the data in these in this small deep field. So you know the deep field is about 20 square degrees. 2 Rubin pointings would cover the Euclid Deep Field South. That's something that our SAC looked at and thought we should go ahead with. So we're doing that. We have run it through our survey cadence optimization committee, and it doesn't impact what else we're doing. So those were the two criteria that we set for ourselves to be able to participate in this activity with the Euclid Consortium. And we're basically at the point now where we're trying to write a detailed MOA about how this would happen. And of course, you'll hear a lot more about it as we get forward toward operations and Euclid gets forward to its launch. We also had a major program in 2021 called the Derived Data Products Working Group. It was led by Leanne Guy and Jean-Charles Qui-André in France, and they brought in about 300 people from both communities to discuss what kind of data products would be most effective in combining to get more science out of the 2 individual surveys. And they produced this report, which you can read online, which recently been updated in a minor way. But that is also a major activity that we see in the future, is how to combine these missions for the best science. And the next step in that case, since none of this activity is funded on either side, either the Euclid or the Rubin side yet, we started with a science-based report, which is what this first report is. And now we're working on what the steps toward implementation might be. And we're working on a so-called letter of intent with Euclid that says, we agree this is great science here. How do we go forward next about trying to make some of this happen? So that's where we're at with Euclid. We also have to consider Rubin. So Rubin is another large survey, of course, that will be coming soon. And so this plot mostly just shows you that there will be an opportunity coming up in the latter half of this decade to combine all three data sets in interesting ways. And we're working with members of all three missions to see how that can happen. In particular, for the Rubin Euclid Roman synergy, we had a workshop earlier this year from the US side. So these are bring in institutions and agencies from the Department of Energy, NASA, and NSF. We obviously have to continue this conversation with our European colleagues, and we are, particularly with Euclid, obviously, to move this forward. So the current activity has looked at the scientific synergies that could occur if you had combined all three data sets at the pixel level, for example. And we're working on how to design an implementation program that would make that happen. Some of the key players here on the US side are Space Telescope and IPAC, SLAC and Noir Lab, of course, who are involved in the Rubin project. We've made great progress this year in setting up our committees, in particular the Science Advisory Committee. We envision will continue through into operations much as it is right now in the construction side. We now have an active users committee that met for the first time this summer, and that has European participation as well. And our Contribution Evaluation Committee, which reviews the in-kind contributions, is still active and working, and we have some more work to do as we go forward on the in-kind program as well. That's an unfortunate 3 bullets that you don't have to pay any attention for that were from earlier this year. The Users Committee has a charge. You can actually, if you download these slides, you can get the charge there and find it, and you can see the members listed here. Some of which are your European colleagues. I know Dominique is here. I'm not sure if anyone else on the committee is here in person. If you are, make sure you say hi and let folks know that you're on the users committee. And these are just a few images of those new folks. We're really excited to have this group helping us out. They will be advising us on all aspects of feedback from the community about how we're doing with our data and our services. Just a few words about sustainability. We realize, we had a lot of time for reflection during the pandemic. We realize it's time to actually do something, probably past time to do something about sustainability. Astronomy itself, as you know, is a very energy intensive per capita endeavor. And we certainly have to change our ways if we're going to make a difference for ourselves and the planet. I'm happy to say that our data facility at SLAC in California is a very energy efficient building. The Noir Lab itself is adding photovoltaic systems to its observatory sites all the way from Hawaii to Arizona to Chile, and as well our base facility sites. So we have now funding to accomplish a bunch of this, but not all of it. So we're still planning and working with our federal agencies to get more resources to do more. In particular, we have a plan right now that is funded to make Gemini South Telescope 100% carbon neutral as far as the facility on the mountain. And we're talking with NSF and DOE right now about doing the same for Rubin. We'll know more about Rubin when we get into operations because we're still some uncertainty on how energy intensive it will be. And then in our base facilities, we're implementing more photovoltaic systems based on the lead that Gemini has taken. They're getting somewhere between 20 and 30% of their daytime energy covered by photovoltaic systems already, and have been since about 2015. This is just a quick image of what it would look like in Tucson. This is our headquarters building at Noir Lab, where the headquarters of Rubin Observatory are as well. And that would show you this currently funded activity for photovoltaic systems on our roof there. That's looking down on the roof. If some of you have been to Tucson, that's probably recognizable. That's part of our 5-year proposal that I mentioned earlier. Now, let me just finish with a few words about our operations staff. We're growing as we approach operations. We've hired new scientists, both at SLAC and Noir Lab, directly onto operations. So not people that are hired first in construction and then go forward. And we're happy to have them on board. Most of those have come into the community engagement activities. So you might even be connecting with them sooner rather than later if you're in the data preview area. There are several construction hires that have been made recently that will transition into operations. From our Aura or Noir Lab side, there's about 77 people coming in. Sorry, that's overall, including DOE, 77 folks coming in. Some of those are actually in kind too as well, at the UK and France data processing facilities, because those folks are starting up activities as well. And there's 29 new people directly to Rubin plus operations. I won't go through these names, but you can look at these as we go forward if you download the slides. Those 3-letter acronyms are the operations department. So I'll just say real briefly, the Rubin Director's Office. Rubin Observatory Operations is everything that happens in Chile. Rubin Data Production is all the producing and processing of data and making it available on the science platform. And the System Performance Department, we already had an RSP, so we had to call it something else, RPF. Handles our systems engineering and our science validation of the data products. And then there's just some nice pictures of the new folks that are coming online. And many of these, again, are in the community engagement team. And you should be able to connect with them soon. So I will finish up here with this slide and then invite Zeljko back up and take your questions and discussion. If there are no questions, we may have to make some provocative statements to see if we can get a reaction out of you, but we'll see. We've made great progress in 2022. We're concentrating all our activities on the development of this plan and getting ready for operations so that we can be productive right away and not have to learn all the things that we could have been learning now. Our team is growing, and we really do make a strong emphasis on building operations in an inclusive and sustainable way. And I really like to see that inclusivity and sustainability, direct connections, hear from you what we can do with the rest of our community, not just at the observatory to make this happen. It has to be a partnership. You know, we all love these meetings, but can we find ways to support each other remotely? For example, there are many things we have to do together if we're going to succeed. So thanks.
Thank you very much.
30 seconds, I forgot something. I was so excited to see you all that I forgot to tell you something. So these two gentlemen, they belong to a French, Slovenian, Croatian collaboration, movie making, scientific documentary, who are producing movie about Rubin Observatory and LSST. So they'll be going around, they'll talk to some people one-on-one, they'll be recording some sessions. If you feel uncomfortable about being recorded, please do let me know and I'll pass this to them.
As a reminder, we have stickers, flag sticker. If you don't want to be filmed, put it on your name tag so that we can see that and you can be avoided or cut out. So we open the floor for discussion now, and we invite the Zoom participants and online participants and Slack to ask questions. And here also we invite especially early stage career scientists to contribute, and everyone to feel comfortable to asking any type of question. Yes.
We have someone watching Zoom. We have someone watching Zoom chat.
Yes, we have.
Oh, okay.
Hi, it's Meg Schwam from Queen's University Belfast. So I really appreciate your talks and sort of giving us a summary. I want to push back a little bit on the schedule that's published on the website, because what I'm finding in the community is that there's more confusion because it's rather a construction project schedule. And so it has a July date. And so it's not factoring into at least members of my science collaborations heads about this contingency, and that really operations is going for a November date or December date. And so I guess the question is how can we communicate that? And are there resources that you have to make that clear? Because I'm finding is that people don't understand the Gantt chart and they're struggling with it says July, so I should be ready for July when, obviously the contingency sort of makes sense to be November to help with planning. So just wondering if you had thoughts about how do I communicate that as a science collaboration chair? And again, how the project and operations together can communicate that better.
You want to go or want me to go?
So we wanted to publish these dates because there needs to be one source of official forecast dates endorsed or carried by the project. That's input to whatever you do with it. And there are at least few different use cases where you would use these dates in different ways. One good example is operations team and their use where they add uncertainty range. So it depends on your application. The construction project cannot tell you what to do with these days. We can only tell you, this is our best current estimate of when we will be done. And we can tell you that we have 4 months of schedule reserve or 5 maybe. And that's the information that is solid, that comes from the project, but then later how you do it, it's depending on use case. I'm struggling myself with my PhD student who I want to do thesis with LSST data, but he's already in the program and there is well-defined 2 years. He needs to take classes and then work on dissertation and then he loses funding. And so now we have to make decision, do we stick to the original plan or do something else? It is very difficult and I can't tell you more than I did. Maybe Bob can offer another word of advice.
Thanks, Meg. I totally agree that it leads to confusion and that we need to improve. In fact, we have talked ever since the PCW about trying to add something from the operations side to that dates page. And I think we will be able to do it. We've talked about actually putting, so as Zeljko said, that actually pulls from real construction project management tools, the actual dates as they currently exist. So we've just had a bit of a discussion trying to figure out how to inject the operations information because we can't put that into the same tools and pull it out. But we will make some kind of page, I think ideally a separate part of that same page that just has independent operations information that will make it clear that we're taking the forecast dates from the construction, we're making an estimate about various uncertainties, and we'll give the range of dates. So totally understand that there's confusion and that we need to be as clear as we can.
Sorry, Adriano Fontana from INAF. I want to come back on the DDP issue with Euclid. If I understand correctly, these are not funded yet, but I understand LSST would benefit from having access to Euclid data and vice versa. So are there plans to make these to find these additional funds? What happens if funds are found on one side only, etc.?
It's a great question. So let me back up and just reemphasize what I said. So where we've started so far is we've had a very large informed community discussion about what combined data products would be most useful for both communities, respecting the desires and the goals of each community. And that's what's in the document. So you can go read all about what the community thinks we should put together. It is true that neither on the Euclid side nor on the Rubin side have we any funds or even, and we're really pressed on our own schedule right now to just get done what we need to get done. So How to implement those data products is an open question that that Rubin leadership and Euclid leadership are talking about right now. And we're at the stage of trying to set up the next phase of this process, which would be an implementation phase. I imagine that phase would ideally look at trying to organize the two sides again to come together to see who wants to do what or who can do what and how to make those data products available once the two missions start taking data. Then it would obviously take some kind of proposal phase to the funding agencies on either side to see what could actually be done. My own view is that somehow, some way, smart people will figure out a way to put these data sets together. Whether or not it's sooner or later is the only real main question. It's an opportunity to do great science. So if one part of the community, the Rubin community or the Euclid community doesn't have resources, but the other does, then there's probably a way to make that opportunity still happen and still share the data, but it's going to be, then it would be driven by one side or the other that comes up with the resources. So it's an opportunity, I think, that that both sides should look toward taking advantage of, but we can't guarantee that either or both sides will be able to do it in a big way, at least on any particular timescale. So I guess what I would say is you have to wait and see how we go forward and what our discussions with our funding agencies would be like as we approach the point where we actually have the two mission data to put together. All I can say is that there's many people on both sides that want to make this happen. And again, everyone thinks it's self-evident almost that this is an incredible opportunity. So. Good.
So thank you so much for the update and the talk. You talked about inclusivity, and on the US side, we have the community engagement team that is working to engage communities that we call underserved in a very effective way, I think. Well, in an effective way, I think, and a thoughtful way. How can we, all the way from ensuring, supporting, and maybe even requiring that the international communities do similar things for their underserved and their marginalized communities, which might be very different from ours and which we might not have visibility into?
Well, that's a great question. And I guess the first step would be, I would love to hear from folks from this side of the Atlantic about what the issues are and where there might be opportunities to engage, and then how we might do that. On the US side, of course, the great advantage that we have is as soon as we identify such a community, it's pretty straightforward to interact with them and envision bringing them into the enterprise and connecting them to the science platform and our community engagement team. With the model for participation in Europe and Asia, and the rest of the world generally being one where you have to have an in-kind contribution and there's only certain people that can access things, then we have to talk about perhaps other ways. And it might be possible, if some community, some part of our European community has a good idea of a small or focused project that could bring in some part of a traditionally underserved community in Europe or maybe even elsewhere in the world. All of us have many connections to Latin America, for example, Africa. Maybe there are ways that we could think of small focus projects where we could bring people in who aren't necessarily data rights holders, but might have a small interaction or of a short time period. So I think it's mostly, let's start having a discussion. Let's talk about ideas. First of all, who are the people that we're interested in engaging with? What are the issues? And then what maybe are the ways that we could help bring them in? I think it really is a tremendous time and opportunity to think about this generally.
Thank you.
Thank you. Thanks for the updates. And so in addition to inclusion, I think sustainability is really important. And it seems like I would feel uneasy to not have that in mind when we see already the effects of climate change. Like in France, for instance, they will have like a hard winter because they have difficulty accessing energy. So it also seems like being self-sufficient would be great. But I didn't get, we're planning to have solar panels at the observatory, and when and how are you going to make this change? And do you have numbers on like the carbon footprint, how it will lower the carbon footprint?
That's a great question. Yes, we do have current plans. We have current funding to start deploying photovoltaic systems at the summit, including for Rubin. Obviously, Rubin isn't in full operations yet, and we don't want to do anything that would interrupt the construction project, obviously, but there are ways to, in parallel, continue to build this infrastructure. So the initial part that's funded for Rubin would supply up to about 20% or so of our daily energy on the mountain. We will begin more detailed planning for that deployment this year, and then we'll just continue to build out as we go forward. We know how much it costs to make the Rubin facility on Cerro Patron in Chile carbon neutral. It's about $15 million. So a pretty large outlay to do that. As you said, there's many good reasons to do it, not the least of which is being sustainable, but it makes our power generation and our operation much more stable, which is an issue that we have currently with commercial power in Chile is often not as reliable as we'd like. So we do have all those plans, at least at a high level, and we're starting to implement them. Our carbon footprint, so I think Dragana mentioned that NOAO and now Gemini and other aspects of the National Science Foundation funding are under one organization called NOIR Lab. So that's the NSF's nighttime astronomy program. NOIR Lab generally is trying to reduce its carbon footprint by about 30% from now, actually a baseline in 2019 to 2027. So over 5 years, we're trying to reduce that carbon footprint by 30%. That's with the currently funded programs. It doesn't include things like adding carbon neutrality for Gemini or Rubin, which are also happening. So I think in the end, we'll hopefully do better. It includes a 50% reduction in travel from 2019 steadily until we get to 2027. And so I don't remember the exact number, but you can do it in yourself. We have a footprint just from the observatories, not including all the travel and other things that our community does or meetings like this, but just from the observatories of about 8,300 tons of CO2 equivalent per year in 2019. We're going to, our plan is, the plan that we have developed and are implementing would reduce that by 30% of that equivalent carbon. And it should be even better than that by the time we get to 2027, because I've said several times that we're actually actively adding more things as we go forward. There's a lot of support and energy at National Science Foundation and DOE to make a difference here. It's I think everyone gets the message that we have to do things. We can't just keep talking about it.
I have a question for Bob. Do these carbon footprint estimates include the impact of air conditioning in hotels at the project community workshop meetings?
No. But your point is well taken. It's often colder in the summer in Tucson than it is in the winter.
So we have a fun question from the Slack, if I can ask. So it's Nushkia Chamba has a fun question to the speakers. And the question goes, what keeps you awake at night? All the things that could either go very well or very badly for the project. For me, it was definitely Zeljko's comment about the great LSST cam lift. So what's your
LSST, what?
the cam lift? So being the project leaders of such a tremendous and complex project?
Well, some of the high-level issues were listed on my slides. I suppose question is about building Rubin and not personal question when I eat too much dinner or something like that. So yes, all the critical lifts are very scary, but we have very experienced team that worked on other observatories that built other very large telescopes. So we are following all the procedures that usually are followed in building great observatories. So I'm not worried too much about things that we know about, the known knowns, and that we are planning for. What I'm worried about is things that nobody thought of and that happened. And examples are like this refrigeration system for the camera. It just happened. We discovered it in measurements, realized physics of that is very complicated. It will take us a year or two to develop real simulation, engineering grade simulation to understand what's going on. And even then, experts in that field could not guarantee that they would be able to quantitatively explain what we are seeing in the lab. So we had to control the processes and switch. So that's an example of something that is unexpected and it happens just like that snow that I showed. So I think the way forward is to carefully think through every remaining step that we have, especially if it involves equipment or there is danger to the team members' safety of people, and just take the time it takes to do it, even if we would run out of schedule, even if we would run out of money. We have to keep safety first. So that's what keeps me awake. What do we do if with that strategy, we then run out of schedule or budget? But these are solvable problems. They are not as irreversible as if you break the mirror or if someone gets hurt or killed or something like that. So that's my top worry.
I guess I would just say I don't actually worry about any of those things because I know we have a great team, and even though there's unknowns that happen and things come up, we've always been able to solve those problems. I have great confidence in the construction team and the operations team that when problems come up, we'll solve them. I guess the thing, and it's not to say I always sleep good, the thing that keeps me up at night is the people, because everyone has some stake in this, everyone has some angle, everyone has some place and something and goals or desires that they want to happen. They don't always line up. And so the thing that I spend the most time worrying about and thinking about is how to make this work for the people so that they get what they need and want out of it. And so, to put it simply, they get along, but that doesn't always happen either. Because they're the ones that have real impact on their lives every day or every month or every year. The technical things, I think we'll solve them. Look, we're in a part of the project right now where every few weeks something amazing is going to happen, and they're going to put something more on the telescope, and it's going to get closer and closer to being the system that we all want. And it's just going to happen. I know it's going to happen. It's happening before our eyes. It's making sure we all get there together and working as a team, and that people get what they need and want out of Rubin because they're putting so much into it.
Thank you very much. We have another question on Slack from Graham Smith. Thank you, Graham. Please, can the speakers comment on progress completing construction of the dome and impact on overall project schedule? Okay.
The situation is complex. I think we still control it to some extent, but the schedule for the final completion of the dome contract, in sense that we signed the dotted line and say we are done, and the team from Italy leaves the summit, is still a year away. Better question is, what delays would we incur because they are not out of the summit, of the building by now as we planned. And I can't precisely answer this question until about a few weeks from now, because the entire project leadership will convene in Tucson in Chile in a few weeks to discuss exactly that question. What will happen now that we will have increased complexity due to unfinished dome? What would happen if we added half of our schedule reserve of 4 months, so 2 months to the schedule and relaxed everything? What impact would that have? There are many similar questions that we will be discussing together. And in few weeks, I will be in position to answer this question in a much more robust way. Right now, we do know there will be additional complexities because the dome contractor team is not out of the building, but we believe we can work around it and continue with completing the construction. There will be an impact on schedule, but quantitatively, I can't tell you how large.
Thank you. Any other questions in the room? If I may allow myself another question. So since we are in Europe, obviously, and there are a lot of European teams here, and I have personally been going around talking about the involvement of the European teams and the in-kind contributions to the people who are not involved in LSST. And I have to say that the interest is growing. Like I was the other day speaking to some Italian colleagues from ENAF who was like, oh yeah, LSST is happening. Yes, we are interested and we want to get involved and so on. So my question would be, and I have received this from several communities, how new teams can get involved? Is there a plan for new in-kind call? Maybe that's a question for Aprijita also on Thursday, but maybe we can start a little bit of discussion already now. So yes, that's my question.
That's a great question. So as I said, one of the biggest challenges was bringing this program in. As you can imagine, it's very large, 150 contributions that need to be planned, reviewed, tracked. That's a huge effort. And so what we're trying to do right now is get this first set of contributions under control. And I think Aprijita is doing a fantastic job of doing that. And get our initial data rights agreements all signed so that we see the totality of the current program. And then we'll go back and look at where are there opportunities to do things that we don't have covered in the current program, where are the places in Europe and elsewhere in the world that want to contribute and bring something to the table. And then we'll look at that and decide how to go forward. We have been telling people, and we will stick to it, that we will look next spring, so about March, to decide whether or not there will be another call. I can't certainly say there will be another call for large sets of in-kind programs, but it seems like a very likely possibility. And we will update the community, the international community, on what the current thinking is by that time. That doesn't necessarily mean there'll be a call next year, but maybe we'll say, okay, in March of 2024, we will do it. This is a really busy time. And so taking on more work right now as we're trying to transition to operations is also something that I have to balance because it's all the same people that have to do that work. But hopefully we'll get this initial program wrapped up and moving forward in a steady way, and then we'll be able to look very carefully about what the next program might look like. And I wanted to add generally to this discussion of international participation, which I think, as Zeljko mentioned and others have, is so important for a vibrant, effective, productive, maximally successful LSST, to use as many people around the world that want to contribute to allow them to do that. So that's certainly something that we take very seriously because we think it's the best way to get science done. What I wanted to say, maybe is a little bit provocative, is I love this meeting, LSST at Europe. The one thing I want to avoid going forward is that we somehow, separate community. So
Absolutely.
having a meeting and bringing people over to talk with you all and what you're interested in and how to make the best out of LSST, great. But having a community that somehow then becomes separate from overall Rubin LSST community is something I think we all want to make sure that never happens.
Thank you very much. We can go at LSST at World. There's another question over there. If I can, I'm going to go there and comment on my way. So what I keep saying to the people who ask me how to join, I say join the science collaboration first. Is that okay?
That's a great answer. The science collaborations are independent of us. We don't control them, but we try and work with them. And that is a very good way to get involved, to understand what Rubin is about and what the science is about, and then how you might actually make a contribution. So I think always joining the science collaborations is a good first step.
Don't you need data rights to join?
But as Mag said,
So-
it depends on the science collaboration. Sorry.
Some of the science collaborations will require that you have data rights, which is up to them. But if not, and they allow you to join, then you should. And I think even if you can't join, I think most of the collaborations would be willing to talk to people about what they're doing and what their programs are and why it would be interesting to be part of what they're doing.
Yeah, just a comment, since I'm the co-chair of the Solar System Science Collaboration. So for our collaboration, we do require data rights because of overheads and ensuring people are information gets spread the right way. But there have been observer statuses in the past. So it depends if there's an active call. It makes it a lot easier than anoint a small number of people to be able to give that kind of interaction. So it does depend on the science collaboration, on the leadership's time and effort and how much they have in terms of infrastructure. So definitely do reach out, but it's just, I think it is still collaboration by collaboration dependent.
Thanks, Meg, for clarification. We have, if you may allow us for one final question before the coffee break.
Thank you. Thank you for the question, by the way. Yeah, I'm very interested in this. And the question is how we should not lag behind, like the new people from Europe who want to join. What should we do to keep up with the pace, right? Because yeah,
The sound of Italy.
yeah. Now, if the new calls may not even appear, how we should deal with like our funding issues, for example, in requesting, funding for new in-kind contributions, deal with the funding that we already have. So can you comment a bit on that?
Unfortunately, I can't give you a simple answer how you should deal with your funding agency in the absence of a specific call from Rubin for new in-kind contributions. The best I can say is please keep talking to me. You know where my email address is, and you can get on Slack and let's just keep talking about your situation.
Well, thank you all for the amazing discussion and amazing session, and some final announcement.